So let's do example 30. Here, guys, I have particles A and B that are traveling around a circular track. So I have a circular track. What does this mean? Circular track means I have a constant radius. So the radius of curvature is constant, and it's equal to the radius of the circle, which is here equal to 5. At a speed 8 meters per second at the instant shown. So, guys, only at this instant, they have the same velocity, which is 8 meters per second. This doesn't mean, guys, that this velocity is constant, not at all, right? It is 8 meters per second at this instant. Now, if the speed of B is increasing by 80B is equal to 4 meters per second, right? So, guys, fortunately, this acceleration of B is constant. So 80B is constant, and this means that I have a uniformly accelerated motion in tangential direction. So I have, for B, I have a uniformly accelerated motion. So this is only for B, it's not applicable to A, in T direction, in tangential direction. All right, and at the same instant, A has an increase in speed that is equal to 0.80 t. All right, so as you can see, guys, ATA is not constant. It is 0.8 times t, which means it is not a uniformly accelerated motion. All right, I should do the integration in order to find the velocity or the position. Determine how long it takes for the collision to occur. So I need to find, guys, the duration it took. Or the duration it takes for a collision to occur. So there will be a collision, right? A will strike B or B will strike A. And I need to find what is the duration so that this collision occurs. And what is the magnitude of acceleration of each particle just before the collision, right? So I need to find the time t at which this collision occurs. Now here, guys, you remember we solved such a problem in rectilinear motion, and in that problem, guys, what we did is to indicate the same origin. Right? So if you remember, we took the same origin from A, and then we said that SA is equal to SB. But this is not applicable here, although you can solve this problem using the same methodology. However, they are, guys, no. They are specifying the origin. They are giving me SA and SB. Okay, and they are specifying different origins for each particle, which means they are they are specifying the origin of particle A as the first point of A, or at the point of A where V is equal to 8 meters per second, and they are specifying the origin of B, of particle B, as this point here, which is the point at which B has 8 meters per second. So they're giving me, guys, different origins. It's not the same origin here like the example we did for rectilinear motion. Now here, guys, I have different origins for different particles, and I'm gonna stick to this given. And then, guys, at the end of this problem, I'm gonna tell you what will happen if we take the same origin. But since they are specifying their origins here in this problem, I'm gonna stick to the given. I'm gonna stick to this SA and to this SB, and I'm gonna solve this problem using different origins. All right, guys? So how to start? I'm going to start by finding VB and SB, since I know that the motion of B is a uniformly accelerated motion. So I'm going to apply the equation VB and SB in uniformly accelerated motion. I know that VB will be equal to AT T plus V0B. Of course, this is ATB, which means that VB, what is ATB? It is 4, and this means, guys, that, and V0B is 8, and this means that VB will be equal to 4T plus 8. Now, how can I find SB? I'm going to apply directly the equation of uniformly accelerated motion, which is half AT squared T plus V0B T plus S0B, right? So what is SB? It is half A T squared plus, of course, A T squared. Don't forget the tangential index, because this is not applicable to the normal direction. Right, S0B. And what this gives me, I know that, guys, since I'm taking the origin at 0 here for B, so this will be 0. All right, guys? This will be 0 because I'm taking B0, so this position is B0 as the origin of B, and A0 as the origin of A. So this will be 0, and this means, guys, that SB will be equal to 2t squared plus 8t, sorry. So this is for B. Now let's do it for particle A. So particle A has an AT that is equal to, what is ATA? It is 0.8T. Yes. And this means, guys, that the integration of dV between A0, which is the initial position, so between VA0 and V, is equal to the integration of AT between T is equal to 0 and T dt. So if you do the integration, this means that V minus VA0, which is 8, is equal to the integration of this value, which is 0.8t squared over 2, 0.8t squared over 2, all right? Which means, guys, that VA is equal to 0.88 t squared over 2 plus 8. This is VA. And then you can find SA using the same concept. So I'm going to do integration of VS between SA0 and S. This will be the integration of V dt between VA0, or sorry, between T0 and T. And this will give me that SA. Now, since, guys, in this problem, we are taking A0 as the origin for particle A, so this will be equal to 0, right? So, guys, for both particles, S0B and S0A will be equal to 0 because for each particle, I'm taking a different origin. It is the origin when V of this particle is equal to 8 meters per second, right? So this means, guys, that that SA minus 0 is equal to the integration of V, and this is also 0, of course, between 0 and T, which is in fact 0.8T, 3 over 6, plus 8. So I'm gonna repeat, Hassan. I said that in this problem, they are giving me the origin. They are giving me different origins. You can see this in the figure. They are giving me different origins. They are saying that SA is going from this point A, which is A0, when V is equal to 8 meters per second. And they are giving me this B. So this is the velocity of B when, this is the position of B when VB is equal to 8 meters per second. And they are saying that this SB is going from this B. So they are giving me different origins, right? Okay. So now I know the equation of SA, the equation of VA, the equation of SB, and the equation of VB. What should I do? What should I do, guys? I have different origins. I cannot say, Hussein, that here in this case, SA is equal to SB. I cannot say this like we did in the rectilinear problem because here I have different origins. So I cannot say that the collision occurs when SA is equal to SB. Never, because I have different origins. If I have the same origin, like if I take the same origin as A0, let's say the position of A at T is equal to 0, then I can say that SA is equal to SB. But since here I have different origins, I cannot say that SA is equal to SB. All right? I cannot say this, guys. So what I'm going to do, guys, what do you think, guys? What should I do? What should I do? I'm going to assume that the collision occurs here. If the collision occurs here, what does this mean? This means, guys, that A is much faster than B. This is SA and this is SB, and they collide here, guys. So if collision occurs here, let's say A is very fast and B is very slow, and then they collide here. A strikes B here. If the collision occurs here, what should I have, guys? This means that SA minus SB will be equal to what? Will be equal to this arc here, from A0 to B0. So it will be equal to this arc. If you do the subtraction, then you're going to have this remaining arc from this point to this point. And what is the length of this arc? It is 240, because this is 240 basically, right? This is 361 120. So it is 240 in radius, which is 4 pi over 3 times the radius. This is the length of this arc. Right? So guys, I'm gonna take two options.